Notes.
All right, good. Then that's good. And my sound.
Hey, Ozzy, we're live on
okay.
YouTube, and I'm going to go ahead and start the webinar.
Okay, thanks, CJ. So Brady, we'll get started in just a second. We'll, allow people to just come on in for a sec, and I'll introduce you, and then you'll talk, and it'll be great. We'll look at all the people coming in. It's fun. It's exciting. It's real life.
And what is I have not done a large group presentation like this. We do lots of meetings. Actually, some of the meetings have lots of people, but everybody's equal in that sense. So people right now, they can still see me, even though I'm presenting. They can see you and me in the presentation. Or
yes, they can see like you in a small window at the corner.
Okay. All right. That sounds good then.
Okay, so I'm going to give it one more second and then I'm going to introduce you. Hi, everybody. Welcome to this lecture. We're going to get started in just a second, just to give folks another minute to come into the Zoom room, Zoom webinar, and then we'll get started with an introduction all about Brady. And Brady will give us a presentation and sort of connect that on some questions from users, and I'll kind of go over that process as well. My favorite part, Brady, of the materials when you sent them to me was the picture that was titled "Brady No Beard." I was like, yes, again, so real life of us, right? To like how we remember our photos that we use for these professional things.
Yes, and well, this was right. I had a beard for, I don't know, 6 years or so, and then only a year ago shaved it off again.
I mean, it's an era. I totally get it. It's like it's even maybe perhaps pandemic related. Who knows?
No, in this case, it wasn't. It happened just before the pandemic, but because I then didn't see a lot of people in person, it was confusing.
Yeah, totally.
Okay. Ooh, just seconds.
Hey, everybody, we'll get started in just a second. I'm going to do Brady's introduction. You'll see at the bottom of the webinar, there's a Q&A capability for you to write questions into the webinar, and I will go over those with Brady as I'm able to. And I know Brady's okay with questions being asked throughout the presentation. So feel free to do that, especially if there's a specific question you have about the user research that he engages in with Google. Okay, Brady, I think I'll get started with your introduction and then let you start talking a little bit. And I sort of just said while you were taking that call that sort of my plan for this was to sort of just give space for folks to put in questions into the Q&A. And if they come up while you're asking things, I'll kind of pose them to you, or just, gently say, hey, I got a question from the audience.
Yeah, that's great.
Okay.
Thank you.
Sure. Okay, so welcome everybody to our fourth Research in Real Life lecture. Today's guest is Brady Hunsaker, who works with Google and works as a software engineer for Google Maps. He works on infrastructure for understanding how people use Google Maps, and he's worked at Google for 13 years, currently in Zurich and previously in Pittsburgh. His previous Google experience includes incorporating public transit stops into Google Maps and understanding the quality of merchants on Google Shopping. Prior to Google, Brady was an assistant professor at the University of Pittsburgh Department of Industrial Engineering. His academic research focused on algorithms and applications of combinatorial optimization. Are these real words? Oh my God. While in Pittsburgh, he served on the organizing committee of the civic-oriented Steel City Code Fest from 2012 to 2015. And he helped establish the Google Pittsburgh's office for K-12 outreach to spark interest in computer science. So thank you so much, Brady, for agreeing to speak with us. And full disclosure, everybody, I know Brady in real life, so it's part of how I roped him in. But go ahead, Brady. Why don't you, take it away?
Yeah, thank you very much for having me. And I didn't realize, I'm remembering now writing that bio up, and it actually has a lot of the talk because the talk is about, right. So part of this talk will be about the parts of my career and different aspects of research that have shown up in the parts of the career. And then the second half will talk more about this brief introduction to user research. And when I get to that, I'll talk more about what that is for folks who aren't familiar. And you were laughing about that. My field was combinatorial optimization. The PhD program I was in was an interdisciplinary program between mathematics, computer science, and industrial engineering. But the name of the program was a big mouthful. It was algorithms, combinatorics, and optimization. And so that was like the.
I mean, you shouldn't be there unless you're ready to say those things, is my opinion.
It would get a laugh when it was in other contexts and people would say, they're so-and-so majoring in this. Okay. All right. Well, hello to everyone out there, all the CalU students. You already heard my name. I'm Brady Hunsaker. I live right now in Zurich, as Ozzy said, but I lived in Pittsburgh for many years. And as I was preparing this slide, I realized I lived in Pittsburgh longer than anywhere else in my life. When I was a kid, we moved around a little bit. And so it's still true. Pittsburgh has been my longest stay. And what brought us there was actually research, a type of research, not for me. Well, that was relevant, but for my wife. My wife at the time was working in public health research, and places that have good public health research are places that have hospitals and universities. And so Pittsburgh is actually, the Pittsburgh region was really great for that. So, and I'll talk a little bit more about some of what I did at Google Pittsburgh and at Pitt when I was there. Okay, so we're talking about my first career, which was as a professor of operations research. And I'm going to talk a little bit about what operations research is. The name for the field itself, for the people who are in the operations research community, the name itself has been a point of discussion and contention because people find it confusing. And it goes to one of the things I'll talk about, and what seems to me what this whole lecture series is partly about, which is that research can mean so much more than what we often first think about. And so to give you a sense of what operations research is, about 15 years ago, the community of people who practice operations research had an effort to try to rebrand it. They really wanted to make it more clear, and their branding effort, which comes across, it's a little bit of, it's marketing, right? But it is a better description, I think, which this very short version was the science of better. And then their one sentence version was the discipline of applying advanced analytical methods to help make better decisions. Operations research is about mathematical models and tools that help people make better decisions. Sometimes it's taking things that on a small scale may be common sense, but then at a large scale, it's not common sense anymore. How do we expand it? Other times, it's even on a small scale, it's not clear what the best is. So, and for that, I will give a couple of examples. Operations research as a field can appear in different departments. So when I was doing this, I was working at Pitt, at the Department of Industrial Engineering. That's often where it is. Sometimes it's with mathematics, and a few places it's with computer science. But if you're familiar with Pitt in School of Engineering, that's where it is. And part of this name, this issue about what does operations research mean, gets to this difference between academic research and research more generally. Part of the reason it was confusing is because operations research as a field really does a lot of applied work. I'll talk about some examples in a moment. But when a lot of people hear that term research, they're thinking academic research. And it's true, I was doing academic research about operations research. But research can mean so much more. And here I looked up one definition to kind of get a sense of what do we mean. And one way to say it is it's systematic and creative efforts to increase knowledge. So and yes, academic research is absolutely one form of that, but I'll be talking about some other cases in my careers where we are doing research. We are looking at problems that we don't know the answers to. We can't just look up the answer. We need to be creative, but we want to come up with a reasoned, good, defensible approach to them. And that is still research. All right. Okay. So operations research, the name comes from its origins. The modern origins of the field come from World War II, and it grew out of originally what were military applications, but now it's used for many, many things. It's not just in the military. And in the military, operations meant organizing and doing things. And research was, as we said before, this systematic efforts to increase knowledge. And so what operations research was originally was how can they look at better ways to do some of their normal operations. And I'll give you an example in a second, but I think it might be easier to think of modern examples that you're used to. So an example of what operations research looks at now is if you're going to the grocery store. So if you're at Giant Eagle, and let's say you're the manager. I mean, one of the questions you have to always answer is how many staffed checkout lanes do I want to have open at any time, right? On one hand, if I have more checkout lanes open, well, the customers like that. That means that they can walk up and check out immediately. They don't have to wait. And so happy customers, which is good. On the other hand, the more that you have open, the more people you're paying. And especially if the staff members are sitting there doing nothing because there's nobody coming up to them, right? You're paying people just to sit there. And that's, I mean, from a business perspective, you can see why the business cares about that. But it's also relevant to the customers, because if it were really important to not wait, they could say, all right, we're going to raise all the prices just a little bit, and then you won't have to wait. We'll staff extra ones. So for customers as well, it matters. I know sometimes it's frustrating, but if you go to the shopping store, what you'd like is that there's always exactly one person in front of you, because if there's exactly one person in front of you, it means the store isn't paying extra to have people sitting there who aren't working. But on the other hand, you didn't have to wait very long. Often, of course, life is not that perfect. So, okay, so that's one example. But another example, again, at the grocery store, is how much of the stock, how much of your merchandise do you want to store right there in the building, versus how much do you want to have in warehouses that you'll have delivered at another time. And there's trade-offs there, of course, as well. If the more you have right in the building, then the easier, you never run out. People never find that they couldn't get what they wanted. On the other hand, you're spending a lot of money to have space in this retail area as opposed to cheaper space in some warehouse. And you're also risking things like maybe some of it will go bad because it's sitting there in a store that people actually don't buy that sort of thing. Okay, so these are standard operations research questions. The ones that that were closer to my part of the field would be, let's say you order something online. I guess stores are open there, right? Here in Switzerland, the stores are open again, but they were closed from January through until March 1st. And so you had to order online, but even if you don't have to, a lot of us order things online. So you order something and it's going to be delivered to you. And let's say it's coming by FedEx Ground or UPS or whatever. Well, they have a challenge. They have all these deliveries that come to them, and they have to say, let's just take the part of the problem where the deliveries have already come to their main warehouse. Now they're saying, tomorrow we want to deliver all these packages. Well, how many trucks do we need to do that? How should we divide up the packages in the different trucks? And where should the trucks drive so that they efficiently are dealing with that? These are operations research problems. These are exactly combinatorial optimization problems. You're trying to find the optimal answer, and combinatorial here means you have a bunch of discrete decisions. This package goes in one of the vehicles. You can't put half the package in one vehicle, half in another, like that. Okay, so that's what operations research is about. And if you're interested in the history a little bit, then here's an example from World War II that they were looking at. Part of World War II was supply. There were lots of resources in the United States that needed to be delivered to the United Kingdom or to the continent once the Allies had a foothold there again. And the shipping across the Atlantic Ocean, this was an important aspect of the war. The Germans knew this as well, and the Germans had submarines that were sinking ships that they could. And when they were sending ships across, what they would do is they'd have a bunch of ships travel together, and that's a convoy, bunch of ships. And one of the things they didn't know was, should we have a really big convoy, lots of ships all go together, or should we have several smaller convoys? Which of these is going to be better for actually successfully arriving in Britain or the continent? And there, the military experts who were used to the problem, they could tell you what the trade-offs were, but they didn't have a systematic answer to how those trade-offs actually balanced out or what was the right decision. So that's just an example of some of the early uses. All right, so if we go on, when I was at Pitt, my academic research was in an area called integer programming. I won't talk about that too much. Partly, I was looking at applications of integer programming, ways you can use it. One of those is FPGA configuration. This is, we're all used to having often in our pockets, smartphones that have general processors, but there's another type of computer called an FPGA that has a flexibility. You can do some configuration on it. And it's less flexible than that general processor, but faster and more efficient in some ways, but it can do a little bit of programming. And so we were looking at how can you efficiently set up an FPGA so that it preserves the good properties. Another one was about organ donations. And I meant to test this before we did it. Let me go back. If I click here, let's see. Do you see my new tab here?
Yes, I do see it.
Great. This is looking at a government website. Organ donations are something we don't think about that much. Organ donations, like if you need a kidney transplant, you need a liver transplant, heart and lung transplant. It's something we don't think about too much, but the country is actually divided up into some administrative regions for organs. And those regions are not purely administrative. Those regions play a role. You are more likely to get a donated organ, depending on the type of organ, from your same region than you are in one from another region. So the way those regions are structured actually matters. And for different organs, it matters how quickly you can get the organ to the patient. Some organs, that's more and less important. We focused on livers. Livers are kind of in the middle, where you can transport them long distance if it was like a really good match to the patient. There's all these aspects of a clinical match. But you can't, on the other hand, there's benefits to using something closer. And so we looked at the problem of, well, what would be the optimal way to divide the country up? And here it shows that the country divided based on states. You don't actually have to divide the country based on states. The country is actually already divided into these organ procurement, I forget what they call them now. Used to be organ procurement organizations. And there, at the time we were studying this, I think there were 59 or 60 of them. And anyway, so the problem there was, how do we best divide up the country? And our goal is to have as many high quality, fast matches of organs. Like there's a chance you actually improve medical outcomes if you do it. One weakness of this research is that we weren't working with the decision makers. We were working with a medical expert I was on the side of the mathematical expertise, but we weren't talking to the people who actually decide. And this is in part a very political decision as well. So it was the sort of research where we could have a chance at influencing policy long term, but it would be more about making people realize you could be doing better. How much better is there? And then get the conversation going. I also looked at algorithms for integer programming, the exact methods that computers used, and I won't talk about these too much because it's harder to explain and I think less interesting probably.
I'm chuckling at you, Brady. I like that you're like, it's, maybe not in the middle of the road here.
Okay. My second career, as I say, that I'm on right now, I'm a software engineer at Google. Originally, I worked in Google Pittsburgh, and the main effort I was on there at the time, at first it was called Google Product Search, and that became Google Shopping. And I don't know how many of you realize that Google has a whole bunch of different parts. And Google tries, you shouldn't have to worry about the different parts of Google most of the time. Of course, you're aware if you use Gmail, Gmail is different. And if you use YouTube and you know that YouTube's owned by Google, which not everybody knows, then that's clearly different. But if we go to Google search, then it's not always obvious that there's different things going on. So I'm going to try that now. One thing I'll warn you about, I am in Switzerland right now. So the results are going to be based on somebody in Switzerland. It'll might not be exact. Well, it certainly won't be exactly what you see. But if I come here and do a search, you don't have to tell Google what type of thing you're looking for. Google is going to try hard to figure that out. And I worked for Google Shopping. Google Shopping, our goal was, let me take a step back. Originally, Google Web Search was finding things on the web. Usually that's, I want a web page with information about this topic. And maybe it's because there's some celebrity you're interested in and you want to learn more about it. You type the celebrity's name, let me learn more about the celebrity. Maybe you're learning about some history and you say, oh, I want to know more about what was going on in the World War II operations research, and find some pages that talk about that. But sometimes you want to buy something. And so Google Shopping is all about, we don't want to show you a web page with information about the thing. We want to show you web pages that are selling that thing and that we know exactly how much it costs. So an example is, let's say we were shopping for ear pods of some kind. So I say ear pods, maybe that's not even the right term, or at least Google thinks.
But Google's so smart it knew, Brady.
Right. We see a mix of results here. And if I scroll down, we see some of the typical ones. So this one here, can you see my pointer?
Yes, I can. I can see it.
Okay, so this top result now, this is more like, I want to know about them. I want to know about earpods, and to some extent they're saying, oh, you can learn about them. Actually, that we happen to know they're selling them on this page too. But the first thing is Google said, we think you want to buy them. If you want to buy them, here's a bunch of places you can buy some different types. And that's what Google Shopping is all about. So within Google, behind the scenes, there's these different parts. Shopping is one. Well, you can actually see the most common ones up here. Images is one. So when they say earpods, Google says, hey, Images, do you think they want to have an image? And Images says, no, probably not, but here are a bunch of pictures of earpods in case you think they want it. Shopping, they say, do you think they want to buy earpods? And Shopping says, yeah, I think they do. Here's some places selling it. And they send it off to News. News, do you think they want news about earpods? And News says, probably not. And, here's some old headlines. Now, if there happened to be some big news about earpods, then News would say, yes, maybe they do, because there was, some big news item. Anyway, so if we come to Shopping, I want to show you I'll go back to my slide for a second, then I'll come back here. An example of the challenges we work on is often different merchants, different online stores are selling exactly the same thing. And they tell us, they send in information to Google and say, here's what I'm selling and here's how much it costs. And here's the URL to the webpage that I'm selling it on. And we don't want to have a bunch of results that say, oh, you can buy the exact same model of Apple AirPods on this webpage and this webpage, this webpage. We'd rather just say, okay, if you want this model of AirPods, here's all the different places you can buy them. But maybe you want something different. Maybe you want a slightly different model or a competing brand. So if we come back to our results, these lower ones here, you can see they're saying, all right, this is the Apple AirPods second generation. And okay, again, I was warning you, these are the Swiss results. So you'll see different things. This is CHF is Swiss francs. So
It feels like I'm on the spring break I didn't get, Brady. It's very exciting. Money and other currencies.
So if you try this, of course, on your websites, you'll see different things because it'll be stores mainly selling to the US. But here it says compare prices from 5 shops. They're saying we know at least 5 shops that are selling the same thing. Well, here's a question. Look at this second one. Apple AirPods second generation. Weiß means white in German. Apple Kopfhörer, that means headphones and headset. Does this look the same to you? It looks the same to me. So here's a case where Google Shopping, what I used to work on, we didn't do a perfect job. Here we thought there's 5 selling this thing, and here we're saying there's at least 25 shops selling this thing. Maybe there is a subtle difference here. Maybe they're actually not quite exactly the same if we looked in, but they might actually be that we made a mistake, and that really these are the same. And this is one of the challenges that's maybe harder than it looks that you don't think about. What we really wanted to be able to do was so this isn't great. Like we look down and these first ones, it's not even clear what's different. Now, finally, we get to some that are at least a different color, and then, oh, wow, yeah. Okay. This maybe wasn't a great example. Or maybe I shouldn't be showing so clearly a case that is quite so hard. What we'd like to do is show you a variety and say, all right, here's these ones, here are some other ones. But this challenge is not trivial because the stores may not talk about or give us identifiers that are exactly the same. And so this is a case where, as I was saying before, there may or may not be an academic research question in here, a question that would be interesting to academics, but there's a real research challenge that Google faces and other shopping sites face, which is, given a variety of information, how do I reliably, correctly group them together? One of the classic mistakes we would have years ago, I think we got a lot better at this, for example, would be we're selling something like a camera. And so you have this high-end camera that could cost $500, $1,000, and somebody else is selling a case for the camera, right? So let's say it's a Nikon, oh, I forget the names, like a Nikon D90 something. Some people say we're selling the Nikon D90, and we say, okay, put all those together. Here's all the different people selling you that camera. But somebody else says this is a case for the Nikon D90. Well, the case is really cheap, right? The case costs $50 or $100 compared to and what we don't want is to say the case is one of the cameras, because then we'll say, oh, the cheapest place you can get it is here. And people are like, that's not the camera, it's the case. And it's a bad experience for the users and it makes Google look bad. And so you really want to avoid that. You want to take the different signals you have, the information they told you, but also the price, and have something that will determine should these go together, should they not. Another challenge is assessing the quality of merchants. And let me go back here. These top ones across the top, these are individuals. These aren't a group of people selling the same thing. These are individual offers from specific stores. Again, you see different ones. Apfelkiste, that means apple case in German. And so this place is mainly about accessories. They don't sell smartphones, they sell lots of accessories, including obviously these ear pods, but they sell cases and things. Galaxus is a big online retailer in Switzerland. It's one of the main ones you would go to. So anybody who shops online in Switzerland is going to know about Galaxus. And similarly, if you shop online, you could buy things from Amazon or Target.com, Walmart.com. Those big companies, you don't really need to know, for most users, you don't need to help in assessing how you feel about them. Everybody has an opinion about Amazon. Either you say, yes, I love it, they're great, and I'm very comfortable ordering from them. Or if you have some concerns about Amazon, you already know it. You say, oh, I don't like this or that, and you make your own decision. But when it's a smaller store, so like I said, Galaxus sort of is that bigger store here in Switzerland, if you've lived here for a while. But Apfelkiste, that's not so big. And one of our challenges was, all right, the smaller store, most people haven't heard of it. How do we assess, is this a trustworthy store? Is this a store that we are happy to point people to? Sometimes people make their own trade-offs. Like we may say, this store has issues with customer service, but when it works and it's really cheap, right? So some people may decide, I'm willing to take a little risk for the cheaper price. So it's not like the stores are absolutely better or worse. But we want to try to provide accurate information. We want to help users as they're making that decision. And especially when they're comparing the store they've never heard of to the store that they know quite well, how can we go about doing that? How can we do it in a way that is both accurate and also a way that makes sense to the users? All right. So those were two of the example challenges we looked at there. About 5 years ago now, I moved to Zurich with my family. And at the same time, I changed the part of Google I was working for. And now I work for Google Maps for the last 5 years. I've been working for Google Maps. And there, the challenges are quite different. One of the first ones I dealt with transit directions. When you ask Google Maps for directions using public transit. If I could see all of you right now, I'd ask how many of you have ever done that, because I'm actually quite curious. The Pittsburgh region, and I guess California especially, is it's more driving territory, but there is public transit. One of our big challenges in transit is that we rely a lot on the different transit agencies to give us information. Of course, we rely on them for their schedule, and their schedule is really a part of what they do, that it's their core job. And so they tend to do that pretty well. But the other thing is we need to know, where are the stops? Where are the bus stops? Or it could be train stops too, but there's a lot more bus stops in the world. And transit agencies aren't always great at that. And actually, one thing I was curious, let's look right now. So you all know your campus much better than me. I'm going to look right now and see. All right, you can tell I just searched. I was practicing and searched for this recently. I want to look at the bus stops on the CalU campus, and you can, we don't really have time for you to tell me. If this were the audience where I could see you, I'd ask, is it right? Oh, did I not click? Sorry. Okay, so here's the campus. We see, let me zoom in just a little. Oh, I'm zooming all the way. They list 3 stops here. You can see these little blue stops. So we have this one. They say Building B and parking, and they say there are 3 buses: the Cal Commuter, the Local 2, and the Weekender 2. And then there's a stop here, Hickory and 3rd. It has those same 3 buses plus the CalU Vulcan FI.
I think it's the Vulcan Flyer.
Oh, the Vulcan Flyer. Oh, that's an FL. Yeah. Okay. And then what do we got? 3rd and University has the Vulcan Flyer, local to Weekender 2. So you know better than me if that's right or not. And this was one of the challenges that I worked on was when a transit agency sends us their information and we want to say, if it matches perfectly something they have sent us before, it's easy. We say, oh, we already know that one. If it does not match perfectly one we've seen before, we have to assess, is this a true new stop that's correct? Is this a stop that has been moved a little bit? And their data was updated a little bit. And that looks really bad if we stick 2 stops right next to each other. And here's some examples of what can go wrong. One example is that they give us the data as latitude and longitude, and they can switch them. So if you work in maps or things like this, you learn latitude and longitude. I don't know if any of you happen to know the Pittsburgh area latitude and longitude. It actually has some nice round numbers. If I click, it will tell us, oh, it's not telling us. Do I have to click? Sorry. There we go. Oh no, I need to be, sorry. Oh yeah, well, it's in the URL. Okay. Sometimes if you're not near an actual address, it will give you a Latin one. I don't know if you can see, can you see my URL?
We can see your URL. Yes, we can see that.
So the first number here is the latitude is 40 degrees north, and the longitude is negative almost 80, negative 79.8. So Pittsburgh region is about 40 degrees north, about 80 degrees west, and the 80 degrees west shows up as a negative 80. So if a transit agency in the Pittsburgh area reverses its coordinates, then it's going to say the latitude is negative 80 and the longitude is 40. Anybody, well, think to yourself, can you guess where in the world negative 80 latitude is with 40 longitude? And we can check here. That should do it. I don't know where these pictures come from. All right, this picture doesn't make any sense, but the description here does. If you see the description, Antarctic ice shield. I'm going to zoom out if I can, so we can actually see. There we go. All right, Antarctica. So if we just take the data they give us, we will plot a bus stop in Antarctica, and we'll say, oh, if you get on the Cal U campus, then you can get off in the middle of Antarctica. And historically, that sort of mistake has happened in Google Maps. We had things showing up in bizarre places. And so our challenge was, how do we catch errors? What kind of errors are likely to show up? How do we tell the difference between a true stop? In this case, it's kind of easy. Nothing should be, there's no transit in Antarctica. I mean, but often many cities, if you reverse it, it's not so obvious. It's still a reasonable part of the world. Another mistake is sometimes they would just give us 0, 0. So there used to be a whole bunch of transit stops at 0, 0, which is in the middle of it's in the Atlantic Ocean, very near the coast of Africa. It's silly. They're not there anymore. We managed to clean that up. But again, if we were thinking about research here, this isn't the sort of academic research question that's going to interest a wide audience, but for Google, it's essential. Here's all this data. We could have a human look at every single one. Even then, it's not good. I mean, if we have a Cal U student look at the Cal U stops, that's pretty good. But we can't find humans in all the right places to look at them. We can have paid employees look at some of them and at least assess, okay, it's in the right city and that sort of thing. But that's very expensive. So our whole goal is, what can we do to try to make it quicker? And in this case, it's mainly about some heuristics. A heuristic means kind of simple rules that can help eliminate the most likely problems. And so simple heuristics will be, it's not more than X number of miles from the other stops in that same set, and if there is another stop extremely close to it, then we want to see some evidence that there it gets harder. Then we might have a human look at it because we want to have a human assess, are these the same stop and they just were updating it, or are they really different because one bus stops here and another bus stops half a block away? Okay, that's enough about that. Another area I worked on is logging of how users use Google Maps. In order to make good decisions about what to do, how to make things better, we need to understand how people are using Google Maps. And whenever you use Google Maps, some information is stored. You have a lot of control over that. So it's not, privacy is a big part of what these systems are about. But we do have some information, and we want to understand how much are people driving in this part of the country? Are they, some of the things we can do with that is, there's one group that looks at questions of, when we give directions, find the places where people repeatedly don't follow our directions, because that probably means something, we don't have something right. We're making a mistake. And let's, narrow in and then explore that. And maybe maybe we said turn right and there's a sign that says no right turn, right? Or maybe our roads are out of date. That's also possible, that it's like, well, you say here, but that's the old on-ramp, that's closed. You have to go a half block further or whatever. Okay. And then for a brief while, I looked specifically at the notifications from Google Maps. This is notifications for Android phones or for iPhones. The notifications are little messages that the apps can send you. And my sense, and quite a bit of us, we felt like Google Maps was sending way too many notifications. It was, one of our concerns was that this isn't, we've gone too far. Each notification might seem useful on its own, but when we put it all together, it was making something that was not so good. And we wanted to better understand which of these notifications are useful to which users, how can we give the users better control so they can say which ones are useful to them personally, and like that. All right, sorry, I'm gonna come back, see if I'm missing anything. Yeah. All right, I think that's it for the part about my career. We're going to transition a little bit. Well, okay. Oops. Before the transition, I was going to say, when you look at tech companies, and I expect it's true of many other companies, but I work at a tech company, and you say, well, what kind of research is going on? There is academic research. There are people at Google and at a lot of these tech companies that are doing what we think of as academic research. One of the hot areas right now is machine learning. And there are people who are just working on general machine learning. It's not necessarily solving any particular problem that Google has, but just trying to advance the state of knowledge. But there is a whole lot of these other research questions where we have a challenge. Nobody can tell us here's exactly how to solve that challenge. So we have to be creative. We have to say what tools are out there, what things do people know. In a few cases, maybe somebody has solved exactly the same challenge or very similar, and we can just use their answer, and that's good. I mean, you don't always want to do things over again. But a lot of times nobody has done quite the same thing, and we have to then say, how are we going to take the information we have and have a good systematic solution? This is part of what makes the job interesting. Okay. So now we'll change gears, and I'm going to talk a little bit about a specific area that we deal with called user research. That is, well, I say specific, that's a very general term, and people may not know it. Sorry, my son is knocking on the window for me.
Love a child during a presentation, Brady. We've all been there.
Here, when we talk about a user, I think this is in the news enough that people are probably familiar, but just in case, a user here means somebody who is using one of our services, an online website or an app, right? I think for physical goods, I don't know if they talk about users the same way. So like if I have my headsets and they're doing their research, I don't know if they talk about consumers or something. But anyway, user is the term for any sort of website or digital app, something like that. Um, and a starting question uh, is, have you ever used a website or an app or even a physical device that you really found it hard to use? You're like, this doesn't make sense. Um, I I think most of us have. This is another case where I'd be curious to look around the room, and more curious if there's people who say, no, I've never had that happen. Um, and sometimes that some people sometimes we have a tendency to blame ourselves, like we say, oh wow, I don't get it, right? Oh, I'm no good with this stuff or whatever. But I think that's I think more often that it wasn't designed well. It has design flaws. It was either not, like, if you are one of the users, there should be some effort to make it work the way you think it should work. Now, it can't work the exact way everybody thinks it can work. There's compromises, but nevertheless, there's a lot of a lot of products out there, digital products especially, that could use better product design. So product design is just the idea of how do we uh, make the product, how do we make the interaction between the user and the product? And if I'm thinking of a website, it means, what do I put on the front page? Where do I put the menu? Which menu items are there? How quickly do you get to the other, if there's other content you want, how quickly can you get there? How easy is it for you to get there? Do I have a place for you to have feedback from my users? If I do, how easy do I make that? Do I show it to the other users? You know, all these ways that you interact with it. With an app is similar to a website, although you can do a little bit more. Apps, the interfaces can do more. The app in a smartphone, for example, it has access to things like your location, and it can access the web itself, and it might have a microphone. You know, well, it should have a microphone access, so it can do a lot more. And then the questions are similar. Are you allowed? Can you talk to it? What kind of interface is there to talk to it? All of these things. So user research, this is a very broad term, and it just means all these ways of better understanding the users who you are trying to build your product for. Partly you're just trying to understand them, but also how they use your product. And I'll talk a little bit more about three different ones: A/B testing, user studies, and the HEART framework, which I'll go into. These three we use at Google Maps. We use a lot more too. There's lots of things, but these I think will give you a sense of what's happening. And you know what? I'm gonna change back to my speaker notes and make sure I'm not missing something I wanted to say. Oh yeah. Part of the reason I chose these is because they have a fair amount of variety. That there are different skills needed, as you'll see as we talk about them, for these different ones. And at a tech company like Google, it's not just a bunch of people typing code. You know, there are lots of people doing critical work who don't like typing code. What they like is thinking about users and what they can do, or thinking about graphical design, user interface to make things both beautiful but also functional. How do you make it look good and be really easy to use, right? So there are a variety of different roles, and that's one of the things I hope to get across here. The first one is A/B testing. Ozzy, is that a term? Do you ever use that? And do you talk about that in your field? I just don't know how widely used it is.
I think that that's a pretty widely used term, and I mean that's in like most textbooks on research and social work, anyways. And I would guess that's probably like pretty interdisciplinary.
Yeah, good. And all it means is we're going to have two groups, A and B, the two different groups. We're going to, usually what we mean is A is going to see the default, the current behavior, if there is a current behavior. And B is you're going to show something a little bit different, or make the interface a little bit different, or the data a little different. Something's a little different for B. And then you're going to compare and say, how did the users in group A behave, and how did the users in group B behave? What does that tell us, and about what we were trying to do? And you may recognize this is very connected to just the scientific method, the scientific experiment. The A group is usually what you would think of as a control group. We're going to leave things normal because we want to have something to know what their behavior would be. And the B group is trying some experiment. And that's the, I mean, we use exactly the language of we run experiments and there's a control group, an experiment group. That's how we talk about it. One of the reasons that A/B testing is really nice to know about, to understand, is that it is so much easier to do with digital products than it is with traditional physical products. I mean, if you imagine, like I'm looking over here at my headset. So if you're the headset company, you can't easily do A/B testing of even if you wanted to do something simple, like you wanted to say, well, this one has the microphone on the left side. Let's try putting it on the right side. Will people like it better, right? Well, you cannot easily, randomly sell some people with it on the left and some people on the right, and then find out whether they like it. It's hard. They can do studies, different types of things we'll talk about. But with Google and with a lot of these digital products, we can just immediately say, we're going to try something a little different for some of these users. And I don't know how many of you realize this. I think a lot of people don't realize this. When you use Google products, you are in a whole lot of experiments all at any given time. And if you take your friend, like you're logged into your account, say, and they're logged into their account. If you're not logged into accounts, it also should be the same. So if you take these two and you look side by side and you look really carefully and look through a bunch of different screens, you will eventually see some subtle different. Well, you might get bored before you see them because so many of them are like little tiny things on screens that you may never go to. But there are these experiments constantly being run so that people are seeing slightly different things. And this is part of why A/B testing is so powerful, is because it is easy to do. And I should say it's powerful because it provides a rigorous way of making a comparison, but it's especially the fact that you can easily do it when you put those together makes it just all tech companies, all digital products are doing this. The other thing is that A/B testing it's not just for big companies. This is something that anybody who let's say anybody with a website, if their website is something where they really are engaging with enough users that it's worth their time, A/B testing is something that's useful. And for example, Google, they're not the only ones, but they have a free online course on A/B testing. And it's not because they're trying to train people to work for Google. It's because all of these websites that Google is indexing, this is a relevant thing for them that they may want to understand. Especially it's true if you're like putting advertising on your website and you want to understand, okay, what might make a difference in the advertising. Then the difference is easier. But let's use something that isn't about money. Let's say you were helping do a website for your community and there was some local political issue with the community. And maybe that's you want better bus service in your community, or maybe it's that the local water company is having a scandal and you want to get people active and aware and to show up. Okay, so if the numbers are small enough, it may not be worth your effort. But when the numbers get big enough, you may want to understand, how can I better get this message across, get people to do this action I want? And A/B testing provides you with a way that you can do it even on a small website, smallish website, where you say, all right, at the same time, some of the people who come to my website are going to see this, and some people are going to see this other thing, and I'm going to collect data about how they behave, and that'll help me decide. And just on a simple one, maybe you say, I'm thinking about changing my menu structure, and so you could just change it and then see if people complain, but then it's hard to know. Some people complain, but other people you didn't hear from. The people you didn't hear from, were they happy? Did they love it? Were they also didn't like it, but they just didn't complain? With A/B testing, it's more rigorous, where you see at the same time, some people get it, some people don't. And then want to look carefully, you need to have some metrics, some things you're going to measure. How much time do they spend on your site? How many of the menu links did they click on? Something like this that gives you a sense of whether they found it clear or whether it was confusing. Okay, so, and I think I mentioned everything on this slide. Yeah, at any given time, you are in a lot of these bee experiments that there is somewhere in Google, if you knew the right corners to look in, there's some button that's a little different. You have a button that other people don't have, or maybe maybe the results are slightly different because they're saying, with you, we're going to try to give more weight to the stores around your area than we normally do. We want to see. Okay. And the other big thing about A/B testing is that statistics are really an important part. You don't have to be an expert in statistics to use the results of A/B testing, as I was saying, if you wanted to make use of this, because there are tools that are there to help handle the statistical part. But you should have some awareness of what's going on. And the techniques themselves wouldn't be possible without statistics. And I gave an example here. Let's say, let's go back to our example of you have this website and what you want is community action about we need more bus frequency. You know, I don't know, in CalU, I guess there's buses into Pittsburgh, right? Maybe you're saying we want better times for those, more frequency or better times for the buses that get us in. And let's say that we had a very simple metric. It's usually more complicated than this. And that is we have a button that says, click here to, you know, send a letter to whoever this decision maker is that you think you want to influence to show. And we just want to know how many people are clicking on that button. And you had a change where you said, originally we had the page this way, and we're going to make a simple change. Maybe we just change the message a little bit. In one case, the wording, our usual wording was, let them know what you think. And maybe your alternate wording, you're like, well, actually, we want to appeal to the community sense and say, you know, show support for your fellow students. You know, and you want to know, did that message make a difference? Well, let's say the numbers are here. In one case, you got 8,259 clicks, and the B version says, now you got, well, not says that you collect 8,420 clicks. Well, that's more clicks, right? Let's assume the two groups were the same size. You got more clicks. So if we had to pick one, we would pick B. But we don't really know if that was just random. Some of the people were chosen, you know, to do it well. Usually it's random or close to random. Maybe just because by chance, the people in your B group were more supportive. And in fact, maybe A is better a little bit, and it was just that randomness. And so one of the central questions of statistics is, how do we think about randomness? How can we differentiate things in the face of randomness? A similar case, in this case, you might say, well, they're pretty close. Maybe it doesn't matter. And that is sometimes a conclusion. You say, oh, well, maybe it didn't matter too much. But sometimes what you're looking at is you make some technical change, and what you're looking at is, did the app crash? Sometimes the app will crash. Hopefully you don't see it very much, but Google Maps crashes. I know because I see the numbers, it crashes. Very small percentage of the time, but we don't like it to go up. And so one of the things, whenever anybody's making a change, we say, are there more crashes? Did they accidentally put in a bug that makes it crash more? Well, by randomness, sometimes there will be more crashes, not because they added any problem, any computer bug, but just the randomness made it happen. And so in those cases, you really want the statistics to be able to say, yes, there were more crashes, but we don't have good evidence that it wasn't just random. Okay, so all of this is to say, statistics has some real value there. And if you have the chance, if you have not taken a statistics class and you have the chance, I encourage you to think about it. Now, statistics sometimes I feel like can be taught in a way that can be boring. And if if the presentation of statistics, here's a way that I think is a bad sign. If they say statistics is about learning these techniques, we're going to learn, this type of inference and this type of ANOVA and whatever. Yes, statistics has a lot of techniques and it's valuable to learn them. The more interesting presentation of statistics, in my opinion, is about these interesting questions. And like a question is, when I'm comparing something like an A/B test, how can I tell if the change was just random? And to me, like that's an interesting question. And if you have a chance to take a statistics course where they bring in those kind of questions regularly, then I encourage you to do so. That's valuable. I think that's valuable in many fields. Ozzy, I guess, in social work, as you're saying, like, well, I know from my wife as well that it is a lot of social workers find it a little more challenging, but it is a key part of the field there as well.
For sure.
And even the other thing is that even if you don't think you are likely to use it in your career, it's hard to know. There's a benefit to having this basic literacy about it because it shows up so much in companies like big tech companies who are using it with you as part of the experiments all the time and to have some understanding of what's happening. Okay, let's go on from A/B testing. User studies. This is a very simple idea. Talk to actual users and watch them. Sometimes you're talking to them, but sometimes you're just watching them use your product, right? This is not a complicated idea, but there's kind of a stereotype, but a stereotype based in fact about software developers who will go build something that works great for them. And like, there's a million buttons and they all have abbreviations that you're not really sure. And the most important button, or for you, you can't even tell where it is and it's hidden with all these other ones. The stereotype is that they build something that works great for them, but not for other people. This is something that we try to remind ourselves, software engineers. We are not usually a typical user of our product. I do use Google Maps, so I am a Google Maps user, but I'm not a typical Google Maps user. I know a lot about how it works, and I think the way I think is already pretty computer logically, and that's not true for everyone. And we want Google Maps to work for everyone, or at least for as many people as we can. Sometimes it goes beyond that. This is also another issue here is accessibility, where I can see colors quite well. So if I say, oh, make the colors like this, that'll help me. Well, there's actually a large percentage of the population that have some form of color blindness. And so you want to actually be careful even in that. There's smaller portions of the population but still have more serious trouble, like are visually impaired. And so can we have a product that actually provides some help in those cases as well? These are other challenges. But even it doesn't have to be accessibility type issues. It can just be, how do people think about, well, I'll give you one example. In Google Maps, when we're Google Maps driving, or giving you driving directions, it has to say, turn right at the next intersection. Well, if you've got a square intersection and you say turn right, that's relatively easy. But what if the intersection is at quite an angle? Then okay. And what if there's not just two roads intersecting, but there's three roads intersecting? And then they'll say slight right, or whatever. In Europe here, we have a lot of roundabouts. They're not as common in Pennsylvania, I think, but roundabouts are where, you enter this traffic circle. You enter this circle and then there's some exits off it. And maybe there's only four. Sometimes they're just at a normal intersection, but they allow traffic to move freely. But sometimes there's five or even more. How do you talk about that? Like, again, this is a challenge, and not everybody would agree on what they find the most useful. So that's another part of the challenge.
I mean, Brady, that's the funniest thing about Pittsburgh ever, right? It's like the turn right to stay on the same street sort of thing in many of these situations. And We have a ton of intersections that are a weird 5-way or even like, like a strange angle. And surely Pittsburgh is a beautiful challenge in this way.
Yeah. But the other another advantage about user studies is that it can be very frustrating and therefore humbling to watch someone try to use something that you worked on. And to do a good user study, you need to have some training in it because this is a very different skill. You are trying to work with, here you're dealing with a small number, one person at a time, and so you're not going to do so many. A/B experiments, Google can send it out to, tens of thousands of people around the world and at the same time. User studies, you're going to deal with a very small number, but you want to empathize with them. You want to make them comfortable and really hear what they're thinking, and not get defensive or judgmental. So usually the user researchers are not the people building the product. They are people who are experts in these skills. And then they come back and talk to the product managers and the engineers. And often the product managers and engineers can observe, sometimes observe remotely, but I did have one opportunity to be observing in person, and they tell you in advance, they give you some training. They say, you can't react, in like sometimes you want to be like, oh, what are they, but the point is, it's easy to think I made this beautiful thing and it's very clear, and you see somebody struggle with it so hard and you're like, why aren't they pushing that button? Look, the button's right there. But the point isn't they aren't pushing the button. The point is the button wasn't where they thought it would make sense. And so user studies are a valuable way to both really see what's happening, but also to try to give software engineers like me a little more humility, a little more empathy with the users we're trying to build for. Okay, so I already mentioned, yes, often, and you use this with other techniques. These techniques, you use them all together. It's not like you pick one and there's only one. As a side note, Google does user studies, and if you think, oh, I would love to be the user in a user study, that you might be able to. There's a link I gave there that Google's always doing research. Other big companies I expect are as well. So sometimes they will do research in different areas. I know they have done it in Pittsburgh in the past. And so if that seems exciting to you, take a look. Okay. All right. The last thing is this framework called HEART. HEART is an acronym, H-E-A-R-T. There's a write-up of it. It's by 3 Google employees, Carrie Rodden, Hillary Hutchinson, and Xin Fu. And this is a framework for thinking about what we call user-centered metrics. A metric is a way that we're going to measure behavior. And the metric I gave before was the click on the button to contact the person who controls the buses, who helps decide. But the metric was, how many clicks are there on the button? Well, by itself, that is not a very user-centric metric. That is a metric kind of centered on the button, who got clicked. And so in a second, in the next slide here, we'll look back at that. Well, I'll tell you what the HERT stands for. The order is not important. The order was made, I believe, just to make the nice word, heart. But what they stand for is happiness, engagement, adoption, retention, and task completion. And this article, there's a link here on the slides. Oh, wait a minute. I can't, the deck itself won't be posted, but I can try to, Ozzy, get you a.
Sure, that's fine, Brady. If you send it to me, I can share it back out. And also we'll have like a end user list of who was in the webinar, which we could send it out to folks if they'd like to.
And yeah, this is, it is public. Also, if you are curious right now, you could probably search and you might, hopefully would be able to find it. It's very short. It's a short article, 4 pages. You could absolutely read it. Any of you students listening, if you're curious about this, take a look and just read the core ideas. So what they mean, happiness is, are the users happy? And there's only really one way to know if they're happy, and that's to ask them. You can't, we have other metrics that we try to use to see if we think they're happy, and that's that valuable. But to really know, you got to ask them. So happiness is usually about some form of survey. The user study we talk about, you do get a sense of happiness there. But if you're trying to get happiness at a larger scale, you can send out a survey to thousands of people and say, tell us what you think. And you maybe get surveys like this all the time. And it's often companies trying to track a similar metric like this. The three in the middle, engagement, adoption, and retention, are ones where we can see this from the logs. I mentioned we log how people are using it. Usually we can see these. Engagement says, it's not how many times was the button clicked? It says, did this same person come back and click the button more than once? And for a lot of things, engagement is good. For example, if you use Google Maps to drive and you are coming back regularly and saying, now take me directions here, now take me to directions here. That's good because, well, Google Maps interprets this as we're serving your need. We're helping you, and you liked it and you came back. So now it's not always, you have to be a little careful in all of these, like that engagement button, that button to contact people. Maybe contacting once made sense. And if somebody is coming back and clicking that every day, that maybe is a bad sign, right? But usually engagement is considered a good thing. And if you think about what it is. And again, the point is not how many times did the button get clicked, it's for a user, how often are they coming back? Adoption is understanding how many of your users are new. Like, do you only have the same users over and over, or do you have new ones? Retention says, it's another view on that same question. It says, do the users you have, are they sticking around long term, or do they sort of fade away? Are you keeping them happy or not? And then the last one, task completion, is to more understand, all right, they clicked on the button, but what were they really trying to do? What was their goal, and what was their whole journey? And are they succeeding on their whole journey? Or not. And that example wasn't great. In driving, for example, in driving directions, your journey is you want to get to the place you're going quickly, safely. If all we know is that you clicked and asked for directions, we don't really know, did we give you good directions? Did you stop them halfway through because they were so bad? Right? And so task completion says, take the user's perspective. What are they trying to accomplish? And then how can we look at that? All right. The last point here is that these, again, show this variety. Some of these are very they're like large batches of data that are easy to collect and need some statistical analysis. Others are smaller groups of data that require a better understanding. If you know anything about surveys, the wording of surveys and the targeting of surveys are really important. You can make your results can be not very useful if you make some major mistakes. So the different skills there come into play. And I mentioned before that at Google, we have a broad mix of skills. That, yes, there are lots of software engineers writing code. That is by far the most among the engineers. But there are a lot of other folks doing critical work to make the products successful. All right. And that is it for my brief introduction to user research. So Ozzy, I think now we can turn to
some Q&A, folks. I don't have anything in the Q&A yet, but I would like to invite everybody, if you have specific questions about any of these, A/B or heart, or sort of any of, Brady talked a bit about his career levels, referring to some as first career, second career. If you have questions pertaining to any of that, please post in the chat. I want to say, Brady, that I really appreciate the examples. I think those really make so much of this like approachable for any student, even if they're not necessarily, in our computer science, computer engineering program at CalU. I was thinking about the terrible interface I use for my role as a soccer commissioner, and it's this program called Affinity, and it is terrible. Like it's as if they've never done any kind of user research and they just want to make it the most painful experience on earth. The like icons are super teeny tiny. You like click on one thing and it'll like destroy the whole like the whole system will implode. It's like very, whew, it's intense. But it's just funny because you're speaking about like the buy back into like why you change that, and for them, I guess they don't really care what the end users want to do. Everybody's like stuck with it because of how those soccer organizations are connected to it. So there's no feedback loop to improve that program.
Yeah.
Oh, we have a Q&A. Oh, okay, good. Thank you, Dr.
I'm gonna
Hunsaker.
stop the screen share. If that does that make sense? Or
Oh
should
yeah,
I-
you can. So here's a question, and this is from Dr. Chen. What advice would you give to CalU students to prepare them for these kinds of real life research?
I think there'll be a chance. Well, I'll be meeting with some software engineering students tomorrow, and the answers there are quite different. But one of the points I wanted to make here is that websites and apps are everywhere, and they can be quite small, modest starting, and or part of a big company or whatever. I mean, even if you don't own your own website, even if you just have some social media account where you've actually gotten enough followers that it's kind of relevant to you, that you want to understand, you're building your follower base, then some of these same questions are relevant. And so one of the pieces of advice is to first of all realize that these skills are a critical part of what all these companies are doing. And so maybe you never thought about a career working on these, because if you're thinking, oh, I'm not a coder, I'm not writing programs, well, the first thing you realize, there's all these elements that are not coding that maybe are interesting to you. And to learn a little bit about what some of those are. And the sort of terms to look up are product manager, user interaction designer, graphical designer, even like survey designer. And so I try to just understand, whoa, maybe there's more going on, and I guess give yourself a chance to think, where might I fit in if I did want to do that. It's not that everybody even would want to do any of those, but it may be more than you realize. If you realize that you really want to pursue some of that further, then I don't have expert advice. I think then I think you would, the best thing for a lot of these is try to reach out to folks and say, hey, who can I talk to that is doing this, and that can, I'm curious, what is it like to be a user interaction designer? Your best bet is to talk to someone who has done some user interaction design. And so you want to then say, who do I know that maybe knows someone? Who can I talk to? And that's trickier. Then you're using your professional network. You may not realize you have a professional network. You have one. Right now, it's probably mostly other students and your teachers, and if you've worked a little, and your parents and your parents' friends. But yeah, talking to folks to get a better understanding, because what I gave is just a little bit of an introduction.
Yeah, I have another question in the chat. In artificial intelligence, is A/B testing that good, since the machine would be making choices for the user?
Let's see.
Interesting question.
Here's a way that A/B testing shows up. So artificial intelligence can be used in different ways, but for example, one type of artificial intelligence is a neural network. This is a very common one nowadays. The neural network, or really any system you have, it has a bunch of parameters. It has been trained to do a certain task, and For example, in Gmail, I don't know exactly the technology they're using, so let me be more generic. In an email system, one of the things that they want to do is identify spam emails and put them immediately in your spam folder, right? And they may be using artificial intelligence to do that. It would make sense. It's one of the key things that artificial intelligence can be good at. Well, they have this model trained that looks at the emails and makes that decision, but that model is essentially a bunch of, it's like this. Yeah, one way to think of it is this artificial intelligence has hundreds of knobs that can be turned a little bit. And the model is one way that they've turned all those knobs based on their training that does a good job. And you update that model though over time. And so whenever you have a new model, slightly different configuration of all the knobs that you think is better, well, you want to do the equivalent of an A/B test to say, I want to compare the new one right up against the old one and make sure that what I'm doing really looks better in the long run. And so then what you're in that way, the A/B are the two different artificial intelligence configurations, the two systems that you're doing. I'm thinking back to the question where it was referring to if it was artificial intelligence looking at A and B. Usually we're thinking about the A/B are users. They are user groups. And if you're using artificial intelligence, what would be different in the A and B group is something about how you're using the artificial intelligence, or as I said, the model you're using, like the exact configuration that you're using. Yeah, so that's the way I would think of it.
Thanks, Brady.
Yeah, also just to be real clear, A/B testing is not going to go away. Users are understanding changes and how users react to them is fundamental. It's not like any technology will help us do that in some way.
I have a question that kind of deals in, since we don't have another one in here, in the end user piece. I end up, I work in a rural place, drive to a lot of rural places. And one thing that flummoxes my use of Google Maps sometimes is connection to a network. And I'm interested to know how that interacts with the accuracy of Google Maps, or because I'll sometimes I'll come off the network and then I lose the rest of my information about like when the next turn was or whatever. Like the directions will still be there, right? The passive directions. And if I've been paying attention, I'm remembering how many miles that was or something. But I'm curious because that is a discussion broadly in the United States now about broadband and connectivity, how that connects into some of the work Google's doing.
So to tie it back in what we were talking about, this is like you want to understand the user journey. And
yeah.
One of the ways that we are not, that I am not a typical user is that I have a relatively high-end smartphone with a relatively high bandwidth data plan, right?
Mm-hmm.
That is true for just about everybody writing that, not just at Google, but at other places, all for the software engineers and the product managers. And a lot of our users, that's not true. I mean, even if you look at where we live, the Google offices are mostly in bigger cities,
urban places, yeah.
And a lot of our users are not, and that's thinking just about the U.S., but think about other countries where it's the norm is to have, in some of them, much lower bandwidth or less reliable. So yeah, it is critical that we are looking at cases, that we are trying cases like this. Actually, one thing I tried doing was there is a version of the Google Maps app for that doesn't use as much, it doesn't take up as much space on your smartphone, and it tries to use less data. And it's designed for low-end devices because Google Maps app just gets bigger and bigger, and people are like more features, but it uses more and more of your memory. And
right.
if you're buying a relatively high-end device, they're getting bigger and bigger to match all these apps. But if you're trying to buy a less expensive device, and then you may be like, oh, I don't want to spend a quarter of my memory on Google Maps.
Right. Totally.
So there are some other versions of it. And I have one installed on my phone because I'm like, I should try using this and see what it's like. And the answer is I get frustrated a lot. Switch it. um, because it is that's more about a different issue about it's kind of a web interface instead of a full app.
Sure.
It affects some of it. Um, but okay, so you were talking specifically about losing data. And yes, this is a common thing. And I would have hoped Google would do better. I thought there's a few things. Sometimes tech companies like to say, "Oh, we have a way you can do that," right? And this is again sometimes a mistake of user research. Like, well, there was a configuration setting that would solve
Sure.
the problem. Why didn't you go to the third page?
Totally. Yes.
And
Zoom asks me to do that all the time, Brady. Zoom is always asking me to go in and change configurations. Yes.
So that is often kind of defensive. And what we really should be saying is you often try to calm down and say, all right, the user had this vision. This is their journey. How can we make that easy?
Yeah.
And, but I thought they did that. I thought actually that Google Maps, when you did driving directions, it downloaded not just your directions, but I thought it tried to download a little bit of the data along your route in case you got off route. But I guess that's not what you were seeing, right?
It wasn't my recent experience, but I also was, again, I have an iPhone 8, full disclosure. So I mean, I don't know, is that like, where does that fall in the spectrum of old? Because I think that's pretty old at this point.
Okay, and here's another danger. This is something we sometimes face in Google Maps. We laugh about this, those of us who work on Google Maps, where we often get complaints about Google Maps, and that's fine. I welcome complaints about Google Maps. That's how I learn. One of the ways I learn. Sometimes the complaints are not about Google Maps, and a number of people have stories, and they'll say, somebody says, "Why are you showing this and this?" And we'll be like, "That's not what I see." And they were looking at Apple Maps.
Yes, I do not look at Apple Maps because I'm not going to say anything bad about Apple Maps other than that I've had enough errors occur that I don't use Apple Maps.
All right, but the takeaway I get here is you're sure it was Google Maps. Okay.
I don't need a specific answer. I think I'm just saying, I think the Wi-Fi thing, especially just in this pandemic year for a lot of our students, and I'm sure, maybe some people watching right now, it's been a real challenge for sure. And I was just curious about how that like configured in, and it sounds like with the heart model or others, that's definitely a consideration in like a beta or whatever, like a different version of the Maps program.
Yeah, I think there's more attention to we want something with less memory and that uses less data, but something that will take you on your journey, on your navigation, even when you lose connectivity. That's a little different.
Yeah.
I thought there were some things automatically in place, but I'm not sure. There is the option, and this is that danger I said before of, well, why didn't you do it this way? You can download data. You can say I want some offline data. And you can say, I'm going to be in this region and I won't have data, or
yes,
it's great if you're going to visit a foreign country, for example, and you don't want to do the roaming. But if you go somewhere that just has poor connectivity, you can say in advance, please download this data. Again, you got to have the space for the data.
But you also have to remember that you're going to have poor connectivity when you're leaving with your 3 kids and you're like in the car and you're like, I was going to have I should have downloaded. Oh no, now I don't know. It's like, that's more so just from an end user perspective, what has happened to me. Then sometimes I very much so try to plan out the trip, but sometimes it's more on the fly. Does anybody else have any other questions before we end with Brady? I didn't see anything else in the Q&A. I just want to say thank you so much, Brady. This was super fun. I enjoyed hearing all about sort of the different ways in which this is, applied. And I really enjoyed your going into examples and really explaining it in a very, I think some of the best teachers I encounter are those who can explain concepts at the middle of the road. And I really saw you do that today, which is a lovely thing, because I think sometimes people can get stuck in jargon or in concepts that are kind of above the level of like, where everybody could attain and understand it. And I think that actually is a testament to the idea of like all the concepts you discussed in terms of like it being something that thinks about the end user. So you were even thinking about the end user as you made your presentation, which again, I greatly appreciate.
Well, you're welcome, and thank you for having me. I wish I could see all the faces of everybody watching.
they're all like me and they're like, thanks. Hello, thank you. So I think I'll have CJ get on and end our live streaming. I know CJ's in a lot of meetings. Thank you everyone for attending. Much appreciated.
All right. Thank you.